Well, hello. Yes, I'm from Wide Field Astronomy Unit in Edinburgh, and I'm presenting work which is done by for a group in Edinburgh, also CASU in Cambridge, who couldn't be here today, but I'll give a few slides about their work too. This meeting is a decade of wide field imaging surveys, but in fact, at CASU and WFAU, we've really been working on these for 2 decades now. I've certainly been there for almost 2 decades, and Nigel and Eckhart and Mike have been there for more than that. So these are right now we don't have all these people working here, and of the ones who are working, it's not all full time either. So we've been archiving data from 3 large imaging surveys over the last couple of decades, from UCURT WIFCAM, from VISTA, and from VST Omega Cam, and we've produced archives in a similar way for these surveys, and in each case for processing of the data in observing blocks from each night has been done by our colleagues in Cambridge, CASU, and they also do calibration, usually on a monthly timescale. So we don't get data in archives for at least a month afterwards, and our release cycles are typically much longer, over kind of 6 months, a year or so. So I'll quickly talk about CASU, and hopefully I won't say anything which will offend Richard or anything like that. So they've again had big teams working on this over the years. Many people moved on to other projects or left, but Mike was kind enough to send me some slides which I'm using. So for CASU, philosophy has been to so they're kind of taking out the instrumental effects. So each of these different instruments has a variety of effects. With WIFCAM, crosstalk and persistence were issues. We didn't really take out crosstalk, but allowed that to be flagged. But in each case, you'll also have the kind of more general dark bias, backgrounds you have to model or subtract depending on your philosophy. You have to do object detection and all the rest of it. So this is the kind of work which CASU has been concentrating on. And they've been working, their projects at the end of their pipeline are these multi-extension FITS files for both images and for catalog products. And so they use that as their bookkeeping. They they don't use too much external software. It's all modular C and Perl and Python codes, and very little external dependencies. So we've all used their products, I'm sure, or the vast majority of us anyway, and we're quite familiar with kind of the good calibrations we get out of these, and the ease of use. And they have a very good website which gives important information about how the images and catalogs are processed and so on. A lot of the work they've done has also been looking at the variations in instrument over time. So sky brightness overnight, and you can see it takes an hour or so to settle down at Paranal, and the effects of 0 point on different WIFCAM bands, and you can see particularly where the telescope, where the silver on an original mirror, the original silver coating degraded badly, in first year of operations in 2011, and then is replaced with an aluminium mirror, which has got slightly different properties, and that has been recoated every so often. So as Richard and others have already talked about, Vista processing was a bit different for WFCAM because of the arrangement of detectors in the focal plane. So with WFCAM, all the detectors were 90% apart. So the paw prints were the basic unit that we used, whereas Vista we use these 1.5 degree by 1 degree tiles, which were made up of 6 paw prints. But processing of paw prints into tiles is not trivial. The PSF varies, the backgrounds vary. So processing of tiles required you to try and take out these effects using nebulizer to make the backgrounds more uniform on the scales which you of the tile, and to use grouting to take out some of the effects of the variable PSF, and then also to take into account the variable MJD across the tile, which you can see here, particularly for surveys like VMC, where you had a longer, where the tiles were produced over about an hour. This became quite significant. On some of the shorter ones, such as VVV, the timescales of a few seconds, it probably didn't matter quite so much, but still, these can be important effects. So moving on to the archive side of it, we have quite a different way we work, and that's really to do with the nature of what we have to do. We're not dealing with processing files in an observing block or minimum schedule block, depending on the terminology of the surveys. We're taking these data and ranging them into programs, so different surveys. So we have, and it's in a database environment. So everything is done within the main archive for that instrument. So we do all our bookkeeping based on archive. So we have Python for most of our work, which connects directly to the archive, and some C++ for some of the faster processes which need heavier computation. And the way we work, we take the FITS files from CASU, we transfer them over and ingest them into archive. And ingestion in catalogs means ingesting into detection table, and in case of images, it's taking metadata and putting those into a bunch of tables. We link images. Now, there's various ways we do that. There's links to confidence images for each main image, but when we have stacks, these come from normal images, and in case of WFCAM, we also had this intermediate microstepped images. When we have tiles, these also link back to their constitutional paw prints, and when we have deep images, we also link those back to the OB images, which we have here. We do quality control. This is partly automated, so checking that all the different image components are there. For instance, checking their things like the seeing, checking other properties, but there's also some input from teams. With CAM, with the UKID surveys, this was done. This was very well organised across all surveys. With Vista, it's very much depended on the team. Some have wanted very high level control, some less so. So it is a bit more of a mixture there, and probably that's there's a variety of surveys, so that's probably a reasonable thing. And we process data on a kind of semester by semester basis, more or less. It depends when agreements for survey releases come about, but when we're ready to do a survey release, we process the data for all the preceding semesters together, but do as much where we don't have to. If deep stacks and tiles and things have already been created, we add to them or create new ones rather than doing everything from scratch, unless we really have to, like there's been updates in processing at CASU, or bugs in software, or improvements we want to make. We band merge data, usually for deepest data in any pointing in each band, but also to get contemporary colors. For instance, Viking has two OBs, two observing blocks, one with, or two types of observing block, one with ZYJ, another one with JHK. So we make deep J band in each one, and then we have also a band merge table with ZY, deep J, J1, J2, so on, and we make colors between the Z and J, sorry, the Y and J1 and J2 and H, and there you get the contemporary colors, which can be very useful for variability study, or at least are less susceptible to variability. And we try and automate that as much as possible. So we can also process PI programs on. We don't have to have a detailed knowledge of the survey to produce the schemas. There's anything which can be automated from data we do. We link team-generated data, and I'll talk about some of that later. Create neighbor tables to external catalogs, so things like Gaia, WISE, all Sky surveys, but as you'll see a little bit later, some smaller ones too. Some PIs have long lists of external catalogs they like to link to, and others not so much. Some surveys have multi-epoch data, and we link that to the main band merged table, which has got so in the band merge table, we also at overlaps assign primary or secondary, so you can create a unique list of astrophysical sources, and we link those to all the different epochs to produce light curves and variability statistics. And then we produce a static data product for users, and in case of Vista and VST, also products for ESO, which often require a bit of conversion. We've both came up with our ways of doing things a bit independently, and they can be converted, but it's a little bit of work. So metadata, we have primary metadata for the whole image, like time, air mass, various other quantities, and then for individual detectors, we have things like 0 point seeing, sky brightnesses and things which go into multi-frame detector table, and all the astrometric ones go into current astrometry. Perhaps we should have just had one table which did both, but that was a decision we made about 20 years ago, and it's a pain to change things. Catalogs. So for each detector, data goes into the detection table. So this has a primary key which has got 3 numbers. One is a multi-frame ID, so the whole image thing, extension for detector, and a sequence number which comes from the extraction of the data in each detector. When we have multiple bands in the same pointing, well, we produce a frame set. A merge log table tells you which particular images go into that, and we produce a band merge table from the detections. If we then produce, if we have multi-epoch data, we then link the source table, which is from band merged table. As I mentioned before, it's you can select a unique list of astrophysical objects from that. We link it to each multi-epoch detection, except the first process is very quick, which is just a simple cross match within a small area, but that gives you that can give you many detections in the same image, or none if there's no object detected, and we turn that into a light curve list where we find for best detection, and we have defaults for non-detections. Say if an object gets too faint in a particular image, and we use that to calculate variability statistics, and also noise model for each pointing, which then allows classification of whether it's variable or not. So neighbor tables. So these are ones just for VMC table. But some of these Gaia will be used, WISE, 2MASS and things will be matched to everything. We can match, 2 billion row tables together very quickly in a few tens of minutes. So this is pretty pretty quick step. The only problems can be where databases which are on external servers get unmounted for one reason or another. That can that's the most annoying bit. So team-generated data. So we produce these pipeline projects I mentioned, but actually a lot of good science comes from more complicated products which are generated by team, because we can't do everything very well ourselves, and there's some very specialized products which are beginning to come, and we do best to link these up. So we produce so when people have produced these, we produce schemas for them, link them into the database, but more than that, we also try to link them up through either neighbor tables or sometimes slightly more complicated arrangements, so you can use the external products, these team-generated products, with the pipeline data, and also use it with, say, external surveys, which I just mentioned, or with other bits, with other team-generated data. So the simplest ones, or the first ones we had, were for deep mosaics from UDS, Video, and more recently UltraVista. Video and UltraVista have also produced their own band merge catalogs where they do different processing to one we have. For VMC, they've been producing PSF photometry. So like VVV and PSF and VMC, both are much more crowded fields, where to get to the depths you want to reach. Aperture photometry doesn't really do it. You need to model all different stars with point spread functions. So, and they have also put some variable type Cepheids and eclipse environments, also RL lyroids, and I think we'll get a bit more of that as well soon. Some of this can be added in after the main release. VVV have done a whole wide variety. 3D extinction maps, I'll show you some of that in a minute. The PSF catalog is for the main VVV survey. Possibly in the future, VIRAC2, which a few people have mentioned, will have multi-epoch PSF catalogs, and we'll try and put those in. Those will be big. I think those will be around 25 terabytes of catalog data. So it's not going to be a trivial thing. We've got proper motion catalogs as well from VIRAC1. Viva 1, so my former postdoc, Carlos Ferrer Lopez, worked on variability indices and then produced Viva variability candidates, and we've linked that in. And there's other variability data sets which we'll also try and put in too. For Ultra Vista have got big plans with the deep equatorial fields. So I don't know if Jim will talk about that tomorrow, but deep optical data from hypersuprime CAM and possibly another source as well, CFHT, is that right? Mid-infrared images and catalogs, and eventually JWST primer with also some HST images and catalogs for a small part of that. So this is a plan in next year or so if we have time. Things. So that would be a very nice data set, and that would also be combining Vista and WFCAM data into the same archive thing. So we have to think carefully about that too. I'll show you these 3D extinction maps. Just give me a second. So this is in the Milky Way bulge around the galactic center, and these are steps in half kiloparsec going out to 10 kiloparsecs, and this is for J-band extinction going up to about 8 magnitudes. So if you're trying to understand stellar populations there, you have to really take into account the extinction. And we link these up to main source tables so you can select large numbers of objects very quickly. We have filter extinction conversion, so you can work in lots of different filters and we have this for 2 different filter extinction curves for Nashiyama and Cardelli. I think there may be others we should put in again. So you can easily produce spectral energy distributions and color magnitude diagrams. When I had more time in past, I thought I might try and add some more in, but I'm not sure that will ever happen now. I think we're spread too thinly right now. We've done a bit with force photometry too. So for some of the deep mosaics, we did dual band image mode photometry rather than just independent extraction on each image. With Ultra Vista DR4, we actually did both. We put the dual band data in a different table rather than the main detection table. And we also produced list-driven multi-epoch photometry and averaged it at different timescales. So because each OB is much shallower than the Ultra Vista deep mosaics, but you can average these hundreds of observations over a few months, 3 months, 6 months, 1 year, so you can get some fainter variables that way. And I also worked with Nick Ross, my phononym, to do a similar thing with 500 QSOs, where we used all the available WFCAM and Vista data and averaged this on some of them were in for UDS or Ultra Vista. Some were we just had 1 or 2 epochs, so it's very heterogeneous data. But we just saw what there was, and here's a couple examples. SDSS J0959 is very faint. It's 24 magnitudes AB, and you see this mix of WFCAM and VERCAM data. So this one had lots, not much variability though. Another one which is a bit brighter, 20th magnitude. Again, not a lot of variability. We didn't really find anything which is. These are Spitzer ones, so a bit yeah. So this is again MJD against brightness. So it looks yes. So you have to be careful not to interpret those as variable. But it's a fun little thing. Data volumes, yes, we're getting, we've got about 2 petabytes of imaging data stored in Edinburgh. About 2,000 WFCAM images night at peak, probably a lot less now, because we're only really getting the UK Hemisphere survey and some University of Hawaii data now. Vista and VST, VST produces a lot fewer, but they're longer exposures. When it comes to catalog data, Vista completely dominates, and VVV completely dominates Vista data because it's much higher density of sources. Vista dominates partly because it's about 7 times faster survey speed than WFCAM. It's got about 3 and a bit times area, twice the sensitivity. Also, because of the processing with both paw prints and tiles, you're getting another 1.5 times factor. So Vista, you get about 10 times catalog data for, and with VVV, with these very short exposures, very high source density, it completely dominates. We've got 80 billion measurements, detections in VVV DR5. Combined VVV and VVVX will be well over 100 billion. That's with just aperture photometry. When you get to PSF photometry, you are getting 200 billion easily. And the final data sets for that, of just catalog data, forget the image data, will be 160 terabytes or something. So archive usage has gone up over the years from about 2010 up to 2022-ish. The number of rows returned has also gradually gone up, down up to about 10 to 10, or maybe all close to 10 to 11 per month. For pixel data, has been a bit more variable. We had a big spike around 2016, 2017. I think that might have been for Viking data with Angus up there downloading it for kids Viking. But yes, we're plenty of usage. It's a bit more variable for VST and right. Okay, got 5 minutes. Good with that. Okay, main releases. So all the WFCAM stuff was mainly under the UKIDS umbrella, at least early releases. Then there's UKIDS Hemisphere survey in more recent years, which is it was J-band only in the first data release, and is J and K and DR2, and I think we'll have H as well in the next data release. Also some PI projects. Some of them we've done some more complicated stuff for. University of Hawaii had a lot of multi-semester programs which we put into one, and they had multi-epoch data taken JHK at the same time, so we produce band merge tables at multiple epochs for them too. So the early data release, about 80 gigabytes, 80,000 images, up to DR11, 3.2 terabytes, and 1.8 million. UHS is about a third of the number of images. And that's J&K across the rest of the hemisphere. Vista has not been this big umbrella consortium. It's been all individual surveys. So it's been a bit more work in some ways, but and as I said, about 10 times catalog data. So last VHS is about 8 terabytes. VVVDR5 is about 55 terabytes of data, but for indices and statistics to make the archive work quickly is another 25 terabytes. And the VV plus VVVX will be massive, and everything else is much smaller. And Atlas one's also fairly small. VFAS we did VFAS for one data release, and we've done Atlas for a lot. So some newest stuff which I'd like to do. So one of the things which has occasionally annoyed me is that people often go back to 2MAS for near-infrared data because, and I think one of the main reasons is that for WFCAM and Vista are spread across lots of programs, lots of surveys, people are not really sure where to look always if they've not been involved in them. Recently, when they had a Euclid press release, people in consortium were comparing for near-infrared images to 2MAS until one of my colleagues kind of pointed them to some of the VMC data, which is much better than 2MAS, similar kind of pixel scale to Euclid. But again, people keep going back to so one of the things was an all-sky catalog, almost all-sky, because you can't get to the North Equatorial Pole because of the mounting of UCURT. And this will be an overlay of the public releases. So you can select a unique catalog, you can find your objects, and then you can go back to the public releases to drill down into data. So here's one I actually made a few years ago, so it hasn't got VVVX in it, and there's some more gaps in VHS still, and you can see even North Equatorial Pole here, but everything else be done. So you've got plenty of. So yes, so this is the kind of idea. You have a database on top of all the existing public releases, so you can go from there using source ID and frame sets to get down to the data here, and then go down to, if you want for multi-epoch data, if you want all the other stuff. One of the issues is sorting out in overlap regions which is primary object and so on. Is it the one which is deepest? Is it one with most bands? Hopefully, so these are questions I have to completely sort out, and also calibration, because WFCAM and Vista are slightly different. They have very similar filters. Z, Y, J, H are very, very similar. K is a wider one for WFCAM than Vista. And the calibration methods that CASU use are slightly different, but all this can be sorted out. Other thing which we'd like to do, which Richard also mentioned before, and we think of doing, we've been speaking to Raphael Shirley about the LST pipeline and processing to get more optimal extended source photometry, because it's not and catalogs which maybe work with some of the extragalactic tools like GalFit and things like that better. I'm not sure if we ever have the manpower to do this, but this is something which we'd quite like to do as well. And how long do I have now? About a minute? -2. All right. Well, this is so. For those of you not familiar, this is what the archive looked like. We have information about how to select data, images, so on, what's contents are, known issues, and things like that. So, yeah, release history, schema browser, SQL cookbook, so you can produce queries, known issues, coverage maps, so you can see how different data sets relate to each other and know where they overlap, and so on. How to do queries, yeah, get nice data, light curves of supernova and so on. External, yeah, okay, I don't have time to do this. Tap services too, so you can have this in your Python code as an API. If you want more information about that, speak to me later. And sorry, I've gone over. Yeah, I think I'll leave it there.